basically simplifying rational expressions. And the bottom line is the only time you can ever take a fraction and reduce it, which is what a rational expression is if you cancel a factor out of the top and the bottom. By cancel, I mean remove or divide the top and the bottom by the same thing. But it has to be a factor, which means you have to factor everything first, and then you can cancel factors common to the numerator and denominator. And remember, your non-permissible values survive all the canceling. You have to look at the non-permissible values before you start and commit to them. If you cancel a factor, doesn't matter. The non-permissible value that factor created is still a non-permissible value. Questions? Go ahead, Seamus. 16? 6b. 6b. Okay, so simplify each rational expression. State any non-permissible values. And in question 6b, we have 3w times 2w plus 3 on the top. And we have 2w times 3w plus 2 on the bottom. I spaced it out that way intentionally. You might be at first glance thinking, well, I can cancel those w's and the 3's and all that, like 2w plus 3. But when you look carefully, it's 2w plus 3 on the top. It's 3w plus 2 on the bottom. And we know that on the top, I know this gets overwhelmingly repetitive, but on the top, that 2w plus 3 is a factor because it's in brackets multiplied by other stuff. The 3w plus 2 is a factor, but I can, without changing the meaning of all of this, I could rewrite it that way. I could say that 2w is 2 times w, so I write 2 in brackets and w in brackets in the denominator, and I could do the same kind of thing with the 3w on the top. And what that means, Seamus, is I can cancel those w's. By the way, your non-permissible values here, well, let me write the solution. The answer is 3 times 2w plus 3 over 2 times 3w plus 2. And the non-permissible values can be written as x cannot equal to 0. Well, not x, I suppose, right? W. W cannot equal to 0 because of this factor. And w cannot equal to negative 2/3 because of that factor. And what you're actually doing here, I think by this stage of the game, most of you understand how to quickly go from that factor to that non-permissible value. But just in case, what you have to do is write 3w plus 2 is not equal to 0, which means when you solve this, you subtract 2 from both sides and then divide by 3. It's probably something you would want to do on a written response. Okay. Other questions? Go ahead. 8C. So we have b squared plus 2b minus 24 over 2b squared minus 72. So you have to run the gamut of different methods of factoring here. You have to, this is almost, we didn't really review factoring per se. We've been factoring all along, but in grade 10, at the top of your list of factoring methods, you should always be looking for a greatest common factor first. And I don't have a greatest common factor on the top, but I do have a factor of 2 on the bottom, so I can factor that 2 out, and I have b squared minus 36. Because when I divide 72 by 2, I get 36, or 36 times 2 is 72. On the top is a trinomial with a quadratic coefficient of 1, which means when we factor the numerator, we're just going to put a b and a b in these two available slots and look for two numbers that multiply to give negative 24 and add to give 2. 6 times 4, if 6 were positive and 4 were negative, that would do the trick. Still nothing we can cancel. I've got 2 factors on the top, 2 factors on the bottom. But the bottom factor of b squared minus 36 can be factored into 2 other factors, because b squared is a perfect square and 36 is a perfect square. And we're subtracting them. In other words, b squared minus 36 is a difference of squares that would factor into b plus 6, b minus 6. Before we get carried away and cancel, well, not carried away, but before we cancel, it might not be a bad idea to write your non-permissible values. And since you have b plus 6 in the denominator, b can't equal negative 6. You also have b minus 6 in the denominator, so b can't equal positive 6. But in the end, the b plus 6's cancel, and we're left with, for an answer, b minus 4 over 2 times b minus 6. Well, that's rotten putting b's and 6's in the same question. They kind of look the same. But is that okay, Alexa? Okay. Other questions? Go ahead, Seamus. 11? What I would say to everybody about number 11 is, in the end, Mike is right, okay? And I think that's, I'll explain it. But in the end, this is the shortcut you want to internalize in your head. You see 2 binomials that are opposites of each other. They look like they're conjugates, but they're not conjugates. The conjugate of x minus 5 would be x plus 5. Those are conjugates. These are opposites. On the top of this, the 5 is positive and the x is negative, and on the bottom, what's opposite? And the bottom line is Mike is right. So anytime you're working on a problem and you see opposites on the top and the bottom, feel free to do this and put a negative 1 wherever you like. You can put it on the top and maybe multiply it into one of the factors on the top. You could put it on the bottom. You could just hang it out in front of the whole thing. You were allowed to do that. Now, I believe that if you internalize that rule, I don't think you have to explain it every time. I don't think even on a written response I care. In fact, I don't care. You don't have to do what I'm about to show you. But some students need to see this because that's how they have to do it. Because they're sticking to the rule which says, Mr. Way said you can only cancel if the factors are identical. So how do I have, if I have 5 minus x over x minus 5, how do I make these identical? Well, one of the ways is I can factor a negative 1 out of what I will call the awkward binomial. We don't normally see binomials written this way, do we? It's usually x and then a number. So if I factor a negative 1 out of 5 minus x, the 5 becomes negative, the x becomes positive. I'm going to show one more step here, but how many of you see that those 2 factors are now identical? I mean, they may be written a little bit differently, but they mean the same thing, because negative 5 plus x is the same as positive x minus 5. All that's important is the negative is in front of the 5, the positive is in front of the x. So now you can cancel these, and if they cancel, of course, then they have to be identical. This is the person who does this is thinking that way, that it only is going to work if the factors are 100% identical. Oh, that was 11. We weren't looking at 13, were we? Okay. Any other questions? All right, let's move on. Today we are going to finish up. We have one little layer of something to do here from yesterday's section in the textbook. So this might even be, well, I guess not. In my note package, it's entitled 10.6.2 Part 1 and 10.6.1 Part 2. We're just finishing up a bit from yesterday. So we're going to simplify rational expressions today that contain different variables. What does that mean? It means the rational expressions will have not just x, but maybe x and y. And we're also going to be multiplying rational expressions. But I'll tell you what, the only difference basically between multiplying two rational expressions and simplifying a single rational expression, which we learned yesterday, the only difference is one of volume. There's just more work to do, but you're doing the same work. Okay. So to begin with here, this is weird. We've got a rational expression which is 16x squared minus 9y squared over 8x minus 6y. And notice I'm not saying what's the non-permissible value. I'm saying what's an expression for the non-permissible values. So we're going to start off by saying, well, the denominator can't be 0. So 8x minus 6y cannot be 0. And let's rearrange that for x. Just because. We could rearrange for y, but I'm going to ask us to rearrange for x. If I do that, I can add 6y to both sides and say that 8x cannot be equal to 6y. I can divide both sides by 8. So x cannot be equal to 3/4 y. That's the expression. That's the statement of the non-permissible value. I'm going to come back to that in a bit. Simplify this rational expression. Well, how do you simplify? What do you do first? What do you always do first in this unit? You factor. The top is a difference of squares. It factors into 4x plus 3y and 4x minus 3y. The bottom has a common factor of 2, which would leave us with 4x minus 3y. What cancels? The 4x minus 3y is a factor on the top and the bottom. So we end up with 4x plus 3y over 2, but we have non-permissible values. The non-permissible values is not a number. It's a relationship between x and y. We said, and I can look at it again for you, we said that x is not allowed to be 3/4 y. Period. Question? Aiden? Oh, I thought I saw your hand go up. I'm sorry. You twitched or something, then I saw a motion over there. So x is not allowed to be 3/4 y. So what does this mean? I know there's a specific question coming next that will explain it to you, but let me ask you this question. If we had these two values for x and y, if I had, not two values, if I had y as being 12, would I be allowed to put 12 in for y here if I put 10 in for x? Would that be allowed? Well, I don't know. What's 3/4 times 12? I think it's 9, isn't it? So x is not allowed to be 3/4 of y. If y is 12, x is not allowed to be 9. This is allowed. Let me ask you a question. If x is 9, can I use y equals 14? Yes, because 9 is not 3/4 of 14. If x was 10.5, would I be allowed to use y equals 14? You might want to do a little bit of calculator work there. Wouldn't be allowed, would it? Because 3/4 times 14 is 10.5. This is not allowed. These pairs of numbers are. So it isn't about a specific number for x that's not allowed. It's about a whole bunch of numbers for x that are not allowed for a whole bunch of different numbers of y. The non-permissible values are like non-permissible pairs of numbers. So what's the non-permissible value for y if x is 2.4? Well, what we know is that x cannot be equal to 3/4 of y. And if x is not allowed to be 2.4, we can put that in and we can solve this for the non-permissible value for y. Yeah, and you know what? You didn't even need to rearrange this actually. Now that I think of it, had you written 4x minus 3y cannot be 0, you could have just used that. You could put 2.4 in for the value that x is not allowed to be and solve for the value that y is not allowed to be. So we're going to take 2.4. The way I do this, I'm going to multiply by 4 and divide by 0.3. And I believe you get 3.2. If you want to take 2.4 divided by 0.75, I believe you're going to get 3.2. But I'm seeing some puzzled looks on the faces right now, and I want you to convince yourself that you're going to get 3.2, and I'm starting to see nods. So the non-permissible value for x for y when x is 2.4 is y is equal to 3.2. Now these are non-permissible values, so what we're really saying is these are numbers that x and y can't both have together. Can x ever be 2.4? Absolutely. In fact, it can be 2.4 in every other case unless y is 3.2. That's the meaning behind this weird non-permissible value set. Determine if x equals 1.5 and y equals 2.8 are a pair of permissible values. And if they are, evaluate the expression. I don't know why I said show two ways to determine the answer. Don't worry about that. One of the things you can do here, there's lots of ways to interpret what's going on, but one of the things you can do is figure out what 4x minus 3y is, because there's only one thing that it's not allowed to be, right? It's not allowed to be 0. This cannot be 0. So let's calculate 4 times 1.5 minus 3 times 2.8. And I get negative 2.4, I believe, but I'm going to want some help on that. And it is. That's okay. So now you're asked to evaluate this expression. But remember, everybody, the expression simplified to, I believe, 4x plus 3y over 2, didn't it? Well, let's just put the x and y in there. The other stuff cancels. So we just have to figure out what this is. We're going to take 4 times 1.5 plus 3 times 2.8 over 2. I get 7.2, but I just did that almost on autopilot in my head. So I would like you to calculate what that is. So the expression has a value of 7.2. That's kind of the leftovers from yesterday's lesson. Now we're going to look at multiplying rational expressions. How many of you remember that adding or subtracting fractions is more complicated? You got to deal with that common denominator, all that crap. Multiplying and dividing is pretty easy. We're going to start today by looking at multiplying. Tomorrow we will be doing dividing. Remember, everybody, that rational expressions are, at the heart of the matter, fractions. So whatever rules we have for operations on numerical fractions, we're going to have the same rules for operations on algebraic fractions, which are rational expressions. So if I said to you, without a calculator, simplify this. The rule that you're taught in junior high is that when you multiply a fraction by a fraction, you can multiply across the top and you can multiply across the bottom. Now we're going to do this without a calculator entirely, not even to figure out factors. What are you allowed to cancel? Never, ever at this level start doing this. This is a recipe for disaster. It's going to get cluttered and, I mean, can you do that? Sure, but I don't want you to do that. What you're going to be doing is canceling, which means crossing out common factors of the top and the bottom, which means what do you do first? Factor. Let's factor everything. So what is 30? 30 is, I'm going to take a couple of shortcuts here because the exact method of this is not that important. 30 is 3 times 10, and 10 is 5 times 2. So 30 is 3 times 5 times 2. And 14 is 2 times 7. On the bottom, 12, and really, honestly, everybody, if I gave you these fractions, this is not how you would simplify this. Okay? We're learning that because this is how it would work with numerical fractions, we can do the same approach with algebraic. The 12 is 3 times 4, but 4 is 2 times 2. So 12 is 3 times 2 times 2. 21 is 3 times 7. It's time for a little break here and just check to make sure that the factoring was all done correctly. And I think that's advice that I would give you. 3 times 5 times 2 is 30. 2 times 7 is 14. I think it's good. And then you go, would you be in agreement? I mean, sometimes my brain slips a gear. I think it's good. Hey, there's a 7 and a 7. There's now check this out here. There's a 3 and a 3. And I want you to notice that the 3 on the top came from the first fraction on the top that I canceled. And the 3 on the bottom came from the second fraction. And I'm doing that intentionally. I know I could have canceled these 2 3s. I'm doing that intentionally to demonstrate to you that since this is now a single rational expression, because of your rule of how to multiply fractions, it doesn't matter where the factors came from. A factor anywhere along the top with an identical factor anywhere along the bottom is fair game. We're not done yet, by the way. We've got a 2 here and a 2 and a 2 here. We have a 2 here and a 2 here. With numbers, it's harder to see what's left over, but I think we're left with 5 over 3. And you could certainly check that on your calculator. You'll get 5 over 3. I want you to notice that had you decided instead to do this, I'm embarrassed to admit I don't know what 12 times 21 is. I was going to say 252. Had you done this, I hope you can see that it is harder to see that this is 5/3 than to see that it's 5/3 when we look at the factors. That's why multiplying stuff out in mathematics in this area is a fatal mistake. You end up getting bigger things that you can't wrap your head around. Let's try one more quick one. This time what I'm going to do is the following. 2 times 2 over 3 times 5 times 3 times 3 over 2 times 2 times 2 times 2. Can everybody just confirm that I did good there? Do you see the difference between what I wrote here and how I did it the last time? I didn't put this as one big fraction. I left the times there. But remember, if you did, you would still be allowed to cancel as long as you cancel from somewhere on the top and somewhere on the bottom, as long as you're multiplying, okay? No other case. You have to be multiplying. We have a 2 here, a 2 here. We have another 2 here, another 2 here. Across the top, all I have left with is a 3, and I don't see any 3's on the bottom, so what we are left with is 3 on the top over, I guess it's 20, isn't it? 5 times 2 times 2. Now, by the way, unlike what we're doing here, when we do irrational expressions, we would leave it as 5 times 2 times 2. You leave it in factored form. So how do you multiply rational expressions? You cancel common factors on the top and bottom. And it doesn't matter top of the first fraction or top of the second with bottom of the first or bottom of the second. These monomials, I hate teaching these monomials because if I want to stick to my rule to help you understand what you need to do, then I have to write that for 30, that for x squared, this for y, this for 33. Am I going to make it? Yep. This for z cubed. And I think you can certainly take shortcuts in a case like this, can't you? You see what's going to happen. But I want to stick to, just for this, the rule which says you cancel common factors. And again, I know that you know this, but I'm just pointing out that I'm aware that you know it. This is a long way to do this question. But the 11 cancels with the 11. We have a pair of z's and a pair of z's. We have the number 5. We have an x. Oh, look at that. Everything on the bottom is gone, so I don't even need to check to see if I've missed anything that could cancel further. All I have left is, I believe it's 18. 2 times 3 times 3, so I get 18. What else do I have? I have a single x. See, doing this is not the best idea for this type of question because you got a lot to sift through now, right? But I believe I have an x, I believe I have a y, and I believe I have a z. Let's just check. I took the 2 and the 3 and got 18. I wrote an x, I wrote a y, I wrote a z, everything else is canceled. This is my answer. By the way, we do have non-permissible values. Each of those rational expressions had denominators that cannot be equal to 0. B. So what do we do? What do we do? Factor. I mean, I could ask you that. I could ask you 100 questions in this unit, and if you said factor each time I asked you a question, you'd probably still get more than 75% of those questions right. These two trinomials, which are quadratic, are basic trinomials. I'm going to flip back and forth between doing something here. You understand that sometimes, and I think I did it in the last question, I just drew a single line for the whole fraction. And sometimes I'll put a multiplication sign in between. I'm flipping back and forth because I want you to understand it doesn't matter. On the top of the first rational expression, what are two numbers that multiply to give 10 and add to give 7? I would say that's 2 and 5. Oh, that's good because I can see there's an x plus 5 on the bottom over there. It's going to cancel. What are two numbers that multiply to give negative 6 and add to give 1 for the bottom quadratic trinomial? Would be plus 3 and minus 2. It's time to slash and burn. Anything that's identical on the top anywhere with something identical on the bottom somewhere can be canceled. So I'm left with x plus 2 over x minus 2. My non-permissible values are negative 3, 2, and negative 5. Let that second part sink in. that the non-permissible values are -3, +2, and -5. Those are the non-permissible values because before we canceled anything, we had an x plus 3 in the denominator, we had an x minus 2 in the denominator, and we had an x plus 5 in the denominator. Look, if you put in 2 for x, you're going to get 0 up here when you put in 2 for x in this expression, because in that expression is x minus 2. It's a factor of it. Can we simplify x plus 2 over x minus 2? No, you cannot. There is only one factor on the top, and there it is. There is only one factor on the bottom, and there it is. Was that what you were going to ask?
No, I answered my own question.
But have you got it figured out then? Okay. You might be tempted to cancel the x's, and if somebody said, can I cancel the x's? I would say no, because x is not being multiplied by everything on the top and not being multiplied by everything on the bottom. Go ahead. Because these are not negatives of each other. X plus 2 over x minus 2 is not is not 2 minus x over x minus 2. These are negatives. X plus 2 and x minus 2 are conjugates. A plus b, a minus b. They don't cancel. If we ended up with that, absolutely, then the whole thing would reduce to -1. Does that answer your question? Okay. Holy smokes. This is what I'm talking about with factoring. You got to be able to factor this. You got to move on to the next question here. So what I'm going to ask you to do is ignore the y's. Just ignore the y's. In fact, don't do anything to your handout, but I'm going to help you visually wrap your head around this. I am going to imagine that there's no y's. Okay? And then we'll come back to reality. If there were no y's, this would be pretty easy, wouldn't it? Wouldn't this be really, in terms of factoring, this is, child's play. So I would like everybody to factor those 4 trinomials. So this is 4 tasks. What 2 numbers multiply to give 6 and add to give 5? What 2 numbers multiply to give 10 and add to give 7? What 2 numbers multiply to 5 and add to give 6, etc., etc. That's about how long it should take you. You want to be thoughtful enough and careful enough that you don't make mistakes, but not so thoughtful and careful that you're going to spend 5 minutes doing this, because you just can't afford that. Now, I asked you to leave blanks there behind the numbers because the fact of the matter is we do not want, for example, in the top of the first expression to get 3 times 2 is 6. We want to get 6y squared, which means that you're going to have a y here and a y here. This is the only difference, and we've factored these before in grade 10. Just give yourself a pause in your brain here and ask yourself, if you FOIL out that top of the first expression now, do you see how you're going to get terms that have x, y's in them? Hopefully you do, because your outer and inner will be x's times y's, and then the numbers as well. So the difference here, let me get rid of all this stuff now. The difference here is that you're going to have y's in everything. That's all. And we're going to cancel common factors. I see an x plus 5y on the top and the bottom. I see an x plus 2y on the top and the bottom. I see an x plus 3y on the top and the bottom. And all we're left with is x plus y over x minus y. I cannot simplify those. Those are not negatives of each other. Interestingly enough, same as the last example. We have non-permissible values. X plus 2y is not allowed to be 0. X plus 5y is not allowed to be 0. X plus 3y is not allowed to be 0. X minus 1y is not allowed to be 0. And I hope that you see, you could certainly rearrange these for x, right? Like in our first example, we ended up with, what was it? X is not equal to 3/4 y. So you could rearrange all of these for x, but it's not necessary. We're not going to do that. Any questions with that one? Go ahead, Seamus.
If that made its way onto a written response, would you want us to write out all of the non-permissible values?
No.
That
Oh,
x is not allowed to equal?
no. I would want you to write what I've written, but you wouldn't have to write x is not equal to. If I want to test your understanding of that, then I'd put that in a multiple choice question where I say something like, Sally's working on this rational expression and she's used y equals 4.8. What value of x is she not allowed to use? And then you would have to do that work to figure out the x coordinate or the x value. It just keeps growing and growing. What makes this different is 3 of those polynomials are quadratic. Well, all 4 of them are quadratic, but they're not basic ones. They're not ones where you can just say what 2 numbers multiply to give one thing and add to give another. Taking these one at a time, they are quadratic. And by the way, I'm not going to give you stuff in a rational expression in this unit that's not factorable. Okay? We don't need to do the b squared minus 4ac test. So I'm guessing it's 5 and 1. That's not really a guess. It has to be 5 and 1. The 6 doesn't have to be 3 and 2. So I don't have to write 3r and 2r. Maybe it's 6r and 1r, but we've learned through experience that more often than not, it's numbers that are closer together. So I'm going to try 3 and 2, and it's hard for me to not look at it and decide where they go. Like if you're like me, I looked at it and I said, well, I need negative 13r. I guess I'm going to put the 3r here so I can bulk up on r's by getting 15r for my inner product. If I put the 2 here, my outer product is 2r. So you know how typically when I give you this thing to factor, I might spend literally 60 seconds explaining how to factor it? I'm not going to do that anymore because then it's going to take just 4 minutes on factoring. You should be able to, let's see, 15 needs to be positive. Nope, 15 needs to be negative. And the 2r needs to be positive. You should be able to get to there pretty quickly. On the bottom here, we've got another 6r squared. So I'm guessing it's 2r and 3r, 1 and 1. Here is a tip for you. I have to check it. I think that this is going to be positive and this is going to be negative because if this is positive, then it would cancel with the 3r plus 1. And something's got to cancel here. Now, I don't know. Maybe I'm wrong. If I FOIL this out, I get negative 3r in the middle and 2r on the outer, which is perfect. Gives me negative 1r, which is what I want. Over here, we again have probably be 3r and 2r. Ooh, okay. If it's 3r and 2r, if it's 3r and 2r, then the 4 cannot be a 2 and a 2. Because if you're going to factor the 4 into 2 and 2, you'll be forced to add a 2 with the same binomial that 2r is in, creating a common factor of 2, and there wasn't a common factor of 2. So if it is 3r and 2r, it must be 4 and 1. If. And if it's 4 and 1, the 4 has to go with the 3, because if I put the 4 with the 2r, I get a common factor of 2. Now, maybe I'm wrong. Maybe it's 6r and r. But these are all things you have to weigh in your head as you make these decisions. I think this is going to work out, isn't it? Because I can get 8r here and negative 3r there. Now, what do I do with this? I'm going to do this in two pieces. I'm going to start factoring it outside of the question. There's a common factor of 2. And I can take a common factor of 2 out and be left with 4r squared minus 25. So I have a 2. And then 2r plus 5, 2r minus 5. Because 4r squared minus 25 is a difference of squares. So look, this whole lesson, factor and cancel. Next question, factor and cancel, factor and cancel. I might as well write down the non-permissible values right now. I mean, you should be like quick like a fox here in saying r is not equal to 1/2. R is not equal to negative 1/3. R is not equal to negative 5/2. R is not equal to positive 5/2. And I think somebody asked this question the other day. Could you write R is not equal to plus or minus 5/2? Sure, definitely. This factor of 2 doesn't contain a variable, so it's never going to be 0. We don't consider non-permissible values. What do we cancel? A whole mess of stuff. 2r minus 5, 3r plus 1, 2r minus 1. So what do we have left? Well, whatever we have left is the answer. But I'll write it down. I have 3r plus 4 over 2 times 2r plus 5. And you don't multiply that 2 through. You could, it wouldn't be wrong, but we want to leave things in factored form for various reasons, some of which will become apparent later in this unit. Basically, it's that if you continue to do more operations here, maybe you'll be able to cancel something later. So you want to be able to keep your eye on the factors. That's it. It's like this is just practice. Factor, cancel, factor, cancel. There are also some questions here. I guess I better look at, you don't have page 352 on your handout, do you? Let me take a look at what that is. Yeah, I think you could do some from 352 as well. You don't have to do all these. You know what you have to be able to do? You have to be able to do all of them. Right? I give you something like this, and I understand how if you saw that question on day 1 of this course, you might just make a 180-degree turn and leave. Right? But this is really easy. This one, all the coefficients of the quadratic terms are 1. To factor them should be very simple. When you start to look down here at question 2, let me clean this up. Was it 1, 2, and 7? So I am guessing, give me a second. I don't have 7, it's gone. But when you take a look at, say, number 2C or 2D, your quadratics start to get more complicated. And when you take a look at D, oh no, there's 3 of them. Well, but you multiply and you get one rational expression. Anything on the top anywhere cancels with an identical factor somewhere else on the bottom.